Morning, everyone. Today, we'll be looking at sorry about that. I had to set up my laptop so that I'll be able to share my screen. Morning, students. Today, we'll be looking at data science foundation. So this unit today is probably about understanding the scope of data science and the roles on data scientists. This unit, so what's this unit about? This unit combines powerful technology, sophisticated technology, statistical method, and expert domain knowledge to analyze and gain practical insight from huge amounts of data produced by organization at present business environment. You might be wondering that what is the aim of this unit? The aim of this unit is to introduce a range of data science concepts, data administration and governance, and big data sources. So this is the unit content. This is what we'll be basically looking at for this unit. So we'll be looking at what data science comprises of. We'll also be looking at introducing data science. We'll be talking about mathematical and statistical skills. We'll be talking about applied mathematics and informatics, machine learning algorithms, topics like data warehousing, data mining, data visualization, and cloud computing. Also, in addition, we know that data science comprises of disciplines such as analytics, statistics, and machine learning. And in continuation, we'll also be looking at data structures, scientific computing, scholastic models, project development tools, predictive analytics, and segmentation. In conclusion, we'll be looking at exploratory data analysis. So these are the key terminology. First of all, we have to understand what data is. So as you can see, data is raw facts. This is just a layman definition. Data is a raw fact, figures, or statistics that can be collected, processed, and analyzed. What is data structure? I mean, what is structured data? Structured data, data that is organized and formatted in a way that can be easily searched, analyzed, interpreted, such as data in relational database. Over here, we'll be able to watch a video that talks about what data science is about. Obviously, you can't hear what it is about, but I will definitely include the link to this video later, or maybe send it as an email to you for your personal use or for your personal guide. By the way, if you have any question about this video, you can definitely drop me an email or maybe ask me after the session. And also don't forget that the link to this video will also be available for you on request if you would like to have it. Yeah, thank you for watching the video. So let's get back to the slides. So the next question we have to ask ourselves is, why data science? So data science is the most abundant thing today. So the question is, we have to ask ourselves, what's the most abundant thing today? So the most abundant thing today is data. We literally have data everywhere, which is increasing multifold every day. And another thing about data science is that it is data-driven. It is interdisciplinary fields about scientific methods, processes, systems to extract knowledge or insight from data in various forms, either structured or unstructured. So who is a data scientist? You might be wondering that would a data scientist is. In my previous slides, we can see that in the whole chart, a data scientist is the person that's in the center of it all. So this person does topics ranging from information systems, business, maths, and they're also developers, and they are obviously data analysts. So what is role of data scientist? A data scientist is someone that is responsible for designing and creating process and layout for complex, large-scale data sets used for modeling, data mining, and research purposes. What are the responsibilities of a data scientist? A data scientist selects features, building, optimizing, classifying using machine learning. A data scientist uses state-of-art methods. The process cleanse and verify integrity of data analysis, among other things. This right here is a flow of problem solving in data science. which obviously start from the first one to the last one, which is 6. So from the first one, you make a discovery of what you want to do. You prepare your data, which is the second one. The third one is you model your data. The fourth one is model building. The fifth one is operationalize the data. And the last one is you communicate your results. And the circle goes on and on from 1 to 6 in order to solve problem in data science. So in the chart, I mean, in this diagram, we see the first one being discovery. So what is discovery? So discovery involves acquiring data from all resources identified, either external or internal sources that can help answer business questions. Data can come from anywhere. It can be from social media. It can be from data stream from online sources. It can be data collected from web services. What is data preparation? Data can have inconsistencies like missing values, blank columns, abrupt values, and incorrect data format, which need to be cleaned. So in preparing it, we are required to explore process and condition data prior to modeling. This will help you to spot the outline and establish a relationship between the variables. Model planning. In model planning, we'll define the methods and techniques to draw the relationship between variables. We also apply exploratory data analytics using various statistics formulas. So the common tools used for model planning are SQL, R, and SAS or Access. These are the 3 common tools used for model planning. The next one is model building. So what is model building? This involves developing data sets for training and testing purposes. We also consider whether existing tools will suffice for running the models. We analyze various knowledge techniques like classifications, association, and clustering to build the model. In the diagram below, we see the common tools for model building. We use SAS Enterprise Miner, we use Weka, we use SPS Modeler, we use R, we use Python, and we use statistical. So over here, we can see the decision tree. Here's a decision tree based on different attributes. In the diagram, we see that every decision is different, which is a common thing in data science. The next thing is operationalized. So what is operationalized? We deliver final reports. This involves delivery of final reports, briefings, code, and technical documents. Implement pilot projects in a real-time production environment. Look for performance constraints, if any. Before the last one, we have to communicate the results. In this aspect, we identify all key findings and we communicate it to the key stakeholders. We explain the model and results to medical authorities. That is if we are analyzing a medical data. We also determine if the results of the project are a success or a failure based on the criteria developed. So another topic we need to look at today is predictive model. The predictive model asks to answer a specific question, which classification should I choose? So we have different types of algorithm that we could choose from. Classification algorithm, anomaly detection algorithm, regression algorithm, clustering algorithm, reinforcement learning. Type of learning, we have supervised learning, reinforcement learning, unsupervised learning. So for supervised learning, this is a type of machine learning algorithm that uses a known data set called training data sets to make prediction. The training data set includes input data and responsive values. Also, the supervised learning algorithm seeks to build a model that can make prediction of the response values for a new data set. The next one is reinforcement learning. So reinforcement learning is an area of machine learning inspired by behavioral psychology concerned with low software agents, or to take action in an environment so as to maximize some notion of cumulative reward. The last one on the list is unsupervised learning. Like the name says, unsupervised learning is a type of machine learning algorithm used to draw inferences from data sets consisting of input data without labeled response. That's the difference between unsupervised learning and supervised learning. The new thing we have to look at today is define the landscape of data science. The landscape of data science is vast and constantly evolving, with new tools, techniques, and trends emerging regularly. Some of the key areas in data science include data collection and storage, data exploration and visualization. What is data collection? You might be asking yourself what data collection and storage is. Like the name says, this involves the collection, processing, and data storage of large volumes of data from various sources, such as databases, sensors, social media, and websites. Just to go deeper into it, take a social media, for example, a social media like Facebook, for example. They have thousands of data that is stored somewhere. So an example of where the data is stored, where Facebook stores their data, is called database. Is a database whereby they can retrieve information and obviously like process the information of any user. The last one is data exploration and visualization. This involves the use of statistical and visualization tools to explore and understand data, identify patterns, and gain insights. In the previous slides, we saw a tree chart, which is an example of data visualization. What is machine learning? Machine learning is a big topic in data science and also deep learning. Machine learning involves the development of algorithms and models that can learn from data and make predictions or decisions based on that learning. A popular example is ChatGPT and Google Bard. ChatGPT processes questions that you ask it by the thousands of data accumulated over a long period of time that has been presented to it. So when you ask it a question, it goes back to the banks of data that it has to process solutions for the question that you ask it. So that is an example of a tool that was created using machine learning. Also, we have deep learning and artificial intelligence. This involves the use of neural networks and other advanced techniques to train models that can perform complex tasks such as image recognition, speech recognition, and natural language processing. And a popular example of this is Google Voice or Siri on the iPhone. Take, for example, right now, you use an iPhone. You can tell Siri to help you book a flight. That is an example of artificial intelligence deep learning because it uses speech recognition. Another thing we have to consider is data engineering. This involves the development of robust, scalable, and efficient data pipelines and infrastructures to support data science workflows. Big data analytics. This involves the processing and analysis of large volumes of data using distributed computer platforms such as Apache Hadoop and Apache Spark. Business intelligence. This involves the use of data analysis and visualization techniques to gain insight into business operations and make informed decisions. In the beginning, we spoke about evaluating the key topics of data science. So over here, we'll be looking at that in more in detail. What is statistics? Statistics provides the foundation for data science. Excuse me. As it allows us to make sense of the data we collect and extract insights from it. So key topics in statistics for data science include probability theory, statistical inference, regression analysis, and hypothesis testing. What is machine learning? Machine learning is a key area of data science that involves developing algorithms that can learn from data and make predictions or decisions based on that learning. Key topics in machine learning include, like we said in the previous slides, the key topics in machine learning include supervised learning, unsupervised learning, reinforcement learning, and deep learning. And I gave an example of how ChatGPT and BARD is used, or how ChatGPT is a good example of a machine learning. Lastly, we have data mining. Data mining is the process of discovering patterns and relationships in large data sets. Key topics in data mining include association rule mining, clustering, and classification. We also have data visualization. Data visualization is an important part of data science because it allows us to communicate insights and findings in an easily understandable way. Key topics in data visualization include graphical perception, visual encoding, and interaction design. Data visualization makes a layman to understand what we've done, what our topic is about, or what our finding is about, so that obviously we can present it to the key stakeholders. We also have natural language processing. Natural language processing is the use of computer to understand, analyze, and generate human language. Key topics in natural language processing include text classification, sentiment analysis, and language generation. Big data. Big data refers to the large and complex data sets that are generated by modern computing systems. Key topics in big data include distributed computing, parallel processing, and data storage and retrieval. For this topic, we mentioned Facebook as an example that stores big data, and they are able to retrieve them in what is called a database. Data ethics. Data ethics is an increasingly important area of data science, as the use of data can have significant societal impacts. Key topics in data ethics include privacy, bias, transparency, and accountability. I know some of us know ChatGPT. When ChatGPT started, everyone was afraid of how our data would be leaked to the internet. So when building a data science tool, we have to make notes of the ethics, which includes privacy, because none of us wants our private information to be leaked. online. So building a tool such as ChatGPT, you have to like have that into consideration. What is the role of data scientists in comparison to other IT roles? Data scientists are focused on extracting insight from data, while other IT roles may focus more on the technical implementation of systems and applications. Data scientists are responsible for developing algorithms and models that can analyze data and provide insights that drive business decisions. Another comparison is that data scientists often have a strong background in statistics, machine learning, and data analysis, while other IT roles may have more general background in computer science or engineering. Data scientists must have a deep understanding of statistical models, data structures, and algorithms to be effective in their roles. These are the key comparison between being a data scientist and having a role in other IT. In continuation, data scientists often work with large and complex data sets, while other IT roles may work with smaller, more structured data. Data scientists must be proficient in working with unstructured and messy data to extract meaningful insights. Data scientists often work cross-functionally with other departments such as marketing, finance, and operations to provide insights and recommendation based on analysis. Other IT roles may work more closely with technical teams within the organizations. Data scientists are expected to have strong communication skills and ability to translate technical concepts into non-technical language. Other IT roles may not require as much communication with non-technical stakeholders. So this concludes our topic today on data science and data science foundation. These are the references we used. So the first reference is geometry and topology of complex hierarchic system and big data analysis. Foundation of Data Science, Cambridge University Press, and also data science and its relation to big data and data different making big data. So this is a textbook. So you can refer to ebooks and journals on the module for this unit. Any queries, questions, kindly email the email address in this slide. And also submission of assignments to be done and sent to the email. Assignment submission is after 2 weeks of the completion of the unit and its delivery. This brings conclusion to our first class in Data Science Foundation unit. I'm not sure if anyone has a question. All right. Thank you all for listening and attending this class. I will see you all tomorrow. Thank you very much.